students. So my name is Prem Kumar Vichala. So today we are going to discuss Nephelo-Turbidimetry. So in that I will focus on introduction and basic theory of the Nephelo-Turbidimetry in this lecture. So coming to basic introduction about Nephelo-Turbidimetry. So when electromagnetic radiation, there is light, you can say EMR, which strikes on a particle in a solution. Some of the light will be absorbed by the particle, some will be transmitted through the solution, and some of the light will be scattered or reflected. The amount of light scattered is proportional to the concentration of insoluble particle. So based upon this insoluble particle, the amount of light scattered is proportional to the concentration of insoluble particle. The scattered light may be measured by turbidimetry and nephelometry. So based upon the light scattering phenomena, the blue color of the sky and the red color of the sun at sunset results from the scattering of light of small dust particles, water molecules and other gases in the atmosphere. The efficiency with which light is scattered depends on its wavelength, that is lambda. The sky is blue because violet and blue lights are scattered to a greater extent than other longer wavelengths. And this is the scattering phenomena. So giving the best example of the blue color of the sky as well as a red color of the sunset. So turbidimetry deals with a measurement of intensity of transmitted light, whereas nephelometry deals with measurement of intensity of scattered light. So each incident light, when it passes through a subject, some of the light should be absorbed. The remaining is either transmit or scattered. So for this measurement of this scattered and transmitted light, we are going to use turbidimetry and nephelometry. So turbidimetry measurements are made at 180 degrees centigrade from the incident light, whereas in nephelometry the intensity of the scattered light is measured usually at right angles to the incident light beam. In turbidimetry we use 180 degrees centigrade. In nephelometry we use right angles to measure the intensity of light, either transmit or scatter. Now here we have some factors which affects scattering of light. Majorly concentration of particles, particle size, wavelength, distance of observation, so molecular weight particles, so molecular weight of the particles also one of the factor which affects the scattering of light. So coming to first one, so here I mentioned two different phenomena for concentration of particles. So one is regarding turbidimetry and one is related to the nephelometry. The first one is the concentration of particles, how they affects towards turbidimetry. So generally at low concentration of particles, for scattering of lights, generally Beers-Lambert's law is applicable. So according to Beers-Lambert's law, the concentration of particles should be proportional to the intensity of light. So just go through the equation. So in that, so S is for the turbulence. The turbulence is directly proportional to the concentration. That is S is directly proportional to C. So S stands for turbulence, whereas T stands for concentration of a solution. So I0, IT, these are intensities of incident light and transmitted radiation respectively. And whereas k is the constant which depends on linearity of light, and sometimes t also we can use as turbulence. Then a second phenomena of concentration regarding nephelometry. So in turbidimetry we should focus on turbulence. So here we should focus on scattering of light. So in nephelometry, an equation that describes the relation between the intensity of scattered radiation, intensity of incident radiation, and concentration of particles, where IS, that is intensity of scattered radiation, is equal to the constant into intensity of incident light and concentration. So mostly the intensity of incident light and the constant scattered constant, so is always constant values, whereas Is is directly proportional to the C. That means the instant of scattered radiation is directly proportional to the concentration. Then second one is particle size. The fraction of light scattered at any angle which depends upon size and shape of particles. The amount of scattering is proportional to the square of effective radius of the particles. To control the particle size and shape, sample solution standards must be prepared under identical conditions. So when you are preparing the solutions, you should take care about the following conditions. One is concentration of two ions forming precipitation, then ratio of concentration of the solutions, order of mixing of precipitation, and the temperature at which suspension is prepared. So when you take care of these conditions, so there you can get the proper measurement or proper determination of solutions for their scattered and transmitted light intensities. So this is also, so when small particles and large particles, so this should be measured in nephelometric conditions, whereas more larger particles it should be determined in turbidimetry. Just go to the picture. So how the light is going to be transmit or scatter. So in first one, small particles, so majorly smaller than 1 by 10th of the wavelength of light. Generally, here the scattering of light should be symmetrical. So if the size increases, so approximately 1 by 4th. So here in small particles we have 1 by 10th, here 1 by 4th. So generally the scattering concentrated in forward directions. So whereas in larger particle conditions, the extreme concentration of scattering in forward to direction, and also development of maxima and minima of scattering intensity at wider angles. So this type of particle size may be considered for the determination of nephelometry and turbidimetry. Means how the particle size is effect on the scattering. So here just go with this one. One smaller particle size, so there we can get symmetrically scattering. In larger, we should get asymmetrically, but the particle size is varies. This comes for larger particles, the unsymmetrical scattering maybe takes place, and the unequal distribution of intensity maybe takes place. Then third one, wavelength. The intensity of scattered radiation depends on the wavelength of the incident light. Shorter the wavelength are scattered to greater extent than the larger one. And wavelength of light is chosen in such a way that analyte solution does not absorb strongly. Turbidimetry and nephelometric measurements are carried using white light. Then fourth factor, that is distance of observation. Light scattering decrease by the distance from the light scattering particles to the detector. So the distance should be r square. And finally, wavelength. So in by wavelength, we should get direct relationship. So this for today. Thank you. In next class, we are going to cover the instrumentation and some applications of Nephelo-Turbidimetry.